Hello and welcome to Knowledge Quest Summer Camp's virtual STEM experience. I'm Rocket Science Rail.
I'm Ms. Bowden.
And today we're going to talk about Sir Isaac Newton. So Isaac Newton is known as the father of science today. He's around in about the 1600s. He worked on explaining everything from light to electricity, nature, and much more. Today we're going to learn about his 3 laws. So Sir Isaac Newton's first law was that an object at rest will remain at rest and an object in motion will stay in motion until another force acts on it. That means if you sit a ball down, it won't move until you kick it.
Newton's second law is the force equals the mass times the acceleration. That means that my weight, and if Terrell tried to push me, his weight has to equal mine or higher than mine.
Alright, Newton's third law is every action has an equal and opposite reaction. That means if I sit this here and I thump it, that moves and it also puts force on my finger. Or maybe when you try to push on a wall and it's too sturdy for you to knock it down, it kind of pushes back on you.
So today we'll be doing different activities to state Newton's 3 laws of motion. So as you proceed through the videos, try to think of different activities you would like to do with 3 laws of motion.
Alright, hey guys, welcome to our first activity. Today we're going to talk about Newton's first law. Alright, so Newton's first law is that an object at rest will remain at rest until a force acts upon it. And the other end of that law is that an object in motion will remain in motion until a force acts upon it. That being said, this ball should not move at all until a force acts upon it. It should stay still like everything else in this room. Sometimes forces you can't see have an effect on objects. For instance, the wind, like we talked about last week, or even friction. And we'll talk about that as we show how objects stay in motion. So basically, you've seen that an object at rest will remain at rest until a force acts upon it. And now we'll see how an object in motion will stay in motion until a force acts upon it. So me giving it for the ball of force and rolling it, it should never stop rolling until I stop it. My hand is the force that interrupts the object in motion. So like I said earlier, there are other forces acting on the ball, such as friction from the table and even the wind in the room. But ultimately, an object at rest will remain at rest and an object in motion will remain in motion until a force acts upon it. So now we'll go to Ms. Bowden and she'll tell us about Newton's second law.
For this activity, for Newton's second law of motion, where force equals the acceleration times the mass, we'll be doing a demonstration with a marble and a piece of paper. So the acceleration is always the same, but the mass is very different. And we will test it out right here with the flour. So as it drops, you can tell that the marble has more force than the paper. Okay, I'm going to do it again in case you guys missed it last time. So as you can see, the marble dropped faster than the paper because the marble has more mass than the paper. So that is Newton's second law of motion, where force equals the mass times the acceleration. So next up, I will have Jeremy to come up and do his third law of motion.
Thanks, Anthony, for that great activity too on Newton's second law of motion. Newton's third law of motion states that for every action, there's an equal and opposite reaction. So look at the chair you're sitting in now. Look at the floor you're standing on. You're putting force on that chair or the floor, but the floor or the chair is pushing up, giving you that same amount of force to balance you out. Go get your favorite ball in the house. Mine is a basketball. Now go roll it up against a wall. Roll it up against it softly. Roll it up against it hard. Roll it up against it quick. Just roll it and see what you observe. See if the ball comes back to you. All right, let's try an activity, guys. I'm about 4 or 5 feet away from the wall right here. I'm gonna try to roll it slow and see what happens. Okay. As you see, no one pushed it back. It came back to me because I exerted a force on it and the force came back towards me. Let's see what happened when I do it a little quicker. As you see, it came back quicker because it's a larger force that I put on the ball. See what your ball did. Well, those are the 3 laws of motion. We thank you guys for coming this week. And check out our other videos. Learn more about us. Signing off.